Howdy, greetings, salutations. Thanks for tuning into the Daily Space Weather. Today we've got some coronal mass ejection disagreement. 1,000 years of solar cycles? How about Sunspot 2804, which spontaneously appeared right here underneath my pointer? That is the colorized magnetogram, if you're wondering. Sunspot 2803 has degraded into a plage, an active region with no umbre. Here's a quick look at the fields. There's 304 angstroms. We saw additional coronal mass ejections. Here it is. A very dense region suspended in the middle of that bubble-like coronal mass ejection that will miss the Earth to the west. And when we talk about disagreement in coronal mass ejections, we're talking about the disagreement of the one that happened the day before. And we did a special video about that. Check our older videos there. It is in smAsho.org presents the sun, as well as our daily space weather videos. It's a daily space weather supplemental. Here's a close-up of the northern hemisphere, and you'll see that sunspot 2804, which is already a beta-class sunspot. See that sunspot suddenly, spontaneously appear there. The likelihood of solar flares a little bit higher now, as we see opposite polarity umbre associated with that new sunspot. Here it is in 171 angstroms, and we've got a bunch more custom videos for you toward the end of the video. Great clips there of the emergence of a new sunspot. So pretty much forecasted a sudden uptick in solar activity here, as we saw only activity in the southern hemisphere, and now we see only mainly activity in the northern hemisphere, if you're not counting coronal holes. So here's where stuff is located in the solar system. Stuff like planets and planetoids and so on. There's where things will be in a week. Full moon in 6 days. And if you're up before dawn, you may see a planetary pileup. Here's a star chart. And that yellow line up there, that's the ecliptic, the path which the sun will take across the sky. Let me just animate this to show you what I'm talking about here. You see several planets rising here with the sun, Saturn, Jupiter, Venus, and the sun all rising together. It's a celestial pileup. So the 10.7 centimeter radial flux, the sun's chromospheric and coronal radio output, now at 75, so it has dropped down 1 solar flux unit. There's the 1-year chart to put that in context. And here's the disagreement we're talking about when it comes to the coronal mass ejection that we saw. And you see there's the coronal mass ejection, and this forecast is for like a glancing blow. So expecting a tiny uptick there, at least NOAA is. I would tend to disagree with this based on the coronagraph imagery and the motion of the Earth. So I don't know. What do you think? Leave us a comment below the video. Let us know if you think it'll be a strike or not. But that is the NOAA forecast. So I'm not so sure about that. They're forecasting a period of geomagnetic unrest here late on the 23rd or early on the 24th. I would disagree. Now, let's talk about volcanoes. Check it out. This is Etna's 35-hour periodicity. That's right. Mount Etna has been erupting on a 35-hour periodicity. So if this is going to continue, it could be erupting right now. And yeah, so what's up with that? How is it able to do that? What is the mechanism behind a 35-hour periodicity of the Sicilian volcano, Mount Etna? quiescent, at least when this report was created, were on volcanodiscovery.com. In other news, Suinosejima, volcanic ash not identifiable in satellite imagery, does not mean volcanic ash not identifiable in satellite imagery is not an indication it isn't erupting. It indeed could be. It's probably cloudy. Popocatépetl down in Mexico exploding, flight level 210, 21,000-foot ash plume there. Pacaya, 11,000-foot ash plume as it explodes. Fuego also exploding in Guatemala, 15,000-foot ash plume there. Nevado del Ruiz back on the list. Uptick at Nevado del Ruiz in Colombia. Explosive activities produced a 19,000-foot ash plume. Volcanic ash clouds have dissipated in satellite imagery over Sangay in Ecuador and the Peruvian volcano Sabancaya. We're unable to detect if it's erupting. Please do not attempt a back handspring or the Fosbury flop over Sabancaya. It could be unhealthful. Next, looking at earthquakes over the past 24, we don't see any large quakes. We see a small deep quake in Indonesia, a 4.5 magnitude at 129 kilometers depth. A 4.3 at the Philippines at 218 kilometers depth. So a couple in the 5 range there at Tonga and the Loyalty Islands. Here's one near Taiwan at depth, a 4.7 at 109 kilometers. Another Indonesian 4.9 deep quake. So some deep quakes kicking off here, folks, like this 4.5 at Colombia. That one occurred at 2:29 Universal Time today. And let's move on. By the way, the smAsho stream today was streamed live at twitch.tv/smAshomash. They've got a great mobile app, and the live streaming platform is fantastic. That's why we use it on the regs. Next, thanks to our patrons, the true source of funding for the content. Please consider becoming a patron to ensure and increase the probability, at least increase the probability, that these videos will continue to be publicly visible, free, and available for everybody to view instead of just our patrons. Next, looking at our own website. Have you been to smAshomash.com? You can find our social media links there, as well as links to our merch shops. And we have made some promotional material as we are changing our marketing strategy quite a bit. So we've got 5 designs on our Redbubble store, which is linked at this smAsho merch link right here. You can find also our Teespring stores at smAshomash.com on the homepage, as well as the forum. Thanks to everybody who's signed up there. It's all free at this point. So yeah, we're doing a lot of things. Have you checked it out? We've got promotional materials. You can get mugs and bottles and travel mugs and so on. So yeah, here's the design. And we've actually got some stickers here. So we just got these. The quality is very high. Again, changing the marketing strategy a little bit here. And there's other merch there. There's actually 5 designs at the Redbubble shop. So perhaps check those out. Maybe a Google Bias, or a Dimension of the Year Hell, or a Fauci Committed Fraud bath mat, or the Smash of Hazard products. All linkable at the homepage, smAshomash.com. By the way, if you're viewing on YouTube, press like and subscribe, otherwise the video can't continue, as we're able to see the future and share it with you. But if you don't press like and subscribe, the future will not hold the video continuing. We will have to be stuck here on fire. Also, press the notification bell and share with your friends and foes on social media. They might get mad, they might get happy, and thanks to our new subscribers over at YouTube. Cheers. Cheers, Governor. Cheers. God bless us, everyone. Let's talk about solar cycles. Did the 11-year solar cycle exist 1,000 years ago? Well, there's an article in the journal Nature.com about 11-year solar cycles over the last millennium revealed by radiocarbon tree rings. So our viewers may have seen this chart quite a lot. People forecasting things using this chart right here. This is going back 400 years to when humans had telescopes and could count sunspots on the sun. this is not sufficient data to really forecast major changes in solar activity. So that's 400 years of sunspot observations. Now, if you're a regular subscriber, you may have seen this. We put up a community post last night sharing Anton Petrov's video, which has only got 61,000 views, so make sure you go support him. Did the 11-year solar cyclicity exist 1,000 years ago? Assuming the inverse proportional nature of cosmic rays versus sunspot cycles was similar to now, the answer is yes. Note the graphs in the video showing 1,000 years of likely solar cycles. Do you see a pattern in the 1,000 years of cycles? I don't, and in order to convince people of future solar activity, solar forecasters would be very wise to realize this. There's a lot of nonsense in solar forecasting, and we're interested in none of that. We're interested in facts. And while Anton Petrov and I disagree on lots of heliophysics and cosmology topics, this is a great video for our viewers to understand. Love Dan, aka smAsho. So here's a small clip from the video.
In this beautiful map of solar activity for the past 1,000 years.
Now, how did this work? Well, the way it worked is there was radiocarbon dating done on European wood. So structures that were built in Europe at known periods had the wood tested for carbon isotopes. So the ratio of carbon-14 to carbon-12 likely give us insight into how many cosmic rays were striking the Earth at the time, as higher levels of cosmic rays are associated with lower levels of solar activity. So I want to note two things associated with this little graph right here. First of all, note the amplitude. Do you see a cycle when it comes to the amplitude? The height of these waves. Do you see a cycle there? Do you see any kind of a legit pattern over the past 1,000 years? I certainly don't. Let's talk about the frequency. Notice how these are evenly spaced over the past 1,000 years. What is that? That is the 11-year solar cycle. So it's been going on for at least 1,000 years. Who knows how long? And since mainstream science does not fully understand or believe explanations of what's causing the 11-year solar cycle, it's kind of important to understand this. And again, do you see a pattern here? I don't see any sort of periodicity there to the sunspot cycle. You can find this article on Universe Today, and this is going to be all over the Science Wire. It's a couple weeks old already, but in any case, tree rings reveal 1,000 years of solar activity. And again, this is taken from European wooden structures, providing us a lot more information than 400 years of sunspot cycles. Thanks to our new subscribers over on BitChute as well. There is exclusive content there, and if you're viewing on BitChute, make sure that you also tune in to the YouTube channel, as there is a lot of exclusive content on YouTube and a little exclusive content on BitChute as well. So if you're viewing on YouTube, maybe check that out. Let's do a cosmology segment really quickly. Let's pick a random number using our quantum number generator here between 1 and 1031. Today's number is 445, which we may have done before. Leave us a comment if I'm redoing one here. 445 is Quasar B1334-127, a BL Lacertae / HPQ. I don't know what HPQ stands for. Some kind of quasar. And BL Lacertae objects are objects with a full range emission spectra. These are the hard X-ray transient outbursts from Quasar 1334-127. That's QSO B1334-127, a catchy name. And let's take a look at this object. I have a bit of a photographic memory. Perhaps I will remember if we've seen this one before. Number 445. Let's check it out on the XMM Newton. I'm not so sure we saw this one before, folks. But indeed we did. So let's go back and take a different random object here. Give us another random number here. This one's 393. So let's check 393. It's Galaxy NGC 4151, a Seyfert 1.5, meaning it's an active galactic nucleus, and we should have a good view of this one when it comes to visual analysis. There is the X-ray output, and this one does seem like it's got a bit of a cyclicity there, somewhat over the past 15 years, as this upper right graph. There is the 30-day chart of Galaxy NGC 4151. Let's look at it on SIMBAD, and you can see the brightness of that active galactic nucleus there, with some blue hot stars on the outer regions, and that bright active galactic nucleus. You're actually looking quite directly toward the pole of this one. This is, if you were just a little bit more perpendicular to the plane of this galaxy from your perspective, this would be a quasar. So there it is in infrared light. Here it is on the XMM Newton, the multi-mirror project, and here it is on Chandra. Great view of that there on Chandra. It's Galaxy NGC 4151, which is, again, number 393 at the Neil Gorell Swift-Bat X-ray Observatory. Let's talk about another galaxy, and this one's super interesting in that there are two different rotating portions of it. Part of the galaxy is rotating one way, and the other portion is rotating oppositely. We've got all kinds of hot blue stars here around these areas, and it's not understood how this galaxy does it. It's believed, according to this article, to be a result of a collision with another galaxy, perhaps an example of a lack of tools in the cosmic toolbox. As this doesn't look very much like a collided galaxy to me, what say you? Leave us a comment and let us know what you think about this galaxy, which is known as NGC 4826. How is it doing that? So you can see a lot of dust obscuring. This is a great view of this. We have a great sort of an angular view. It's not quite edge on, and it's not quite perpendicular to the ecliptic plane. Galaxy NGC 4826. How is like half of it rotating oppositely to the other half? Normally when we see galaxies that collided with other galaxies, they're much more irregular in shape. This one has a very regular spiral shape. Perhaps a very slow collision happened. But in any case, that's today's cosmology segment. And let's move on. We don't see any solar flares, although again the likelihood of solar flares is a little bit higher now, as Sunspot 2804 has two opposite polarities, which make it a beta-class sunspot. We've got two umbrae, one North Pole and one South Pole oriented. We don't see any proton strikes. No real surprise there. It's been part of our forecasting. And before we look at the real-time solar wind, let me check the life of the stream, and everything looks just fine. We've finally seen geomagnetic unrest come down to a KP of 3, as we see a fluctuation here of the density and the velocity. Also, the BT-BZ shifted. Actually, two significant shifts in the BT-BZ. This top line, the top line is the total field, and the BZ is the orientation of the field to one of the poles. When you see a negative BZ, that's South Pole magnetism being dominant. And when you see a positive BZ, that's North Pole magnetism dominant. And the BT is the total field. No big shifts in the phi angle. And the BZ has recently moved into positive territory, North Pole orientation. In any case, solar wind density still elevated here at 13.57 protons per cubic centimeter. Solar wind speed still elevated as well at 576 kilometers per second. Don't be surprised to see geomagnetic unrest kick back up again here, as that is a significantly elevated coronal hole wind stream, a significantly elevated solar wind speed. So here you can see the longest series of periods of geomagnetic unrest we've seen so far in cycle 25. Again, KP index now at 2. And thanks, new viewers, for tuning in. The KP index is a measurement of global geomagnetism. Speaking of geomagnetism, here's 4 hours of a geospace magnetosphere movie. And this model is created using the space weather modeling framework, which uses a lot of data. If you want to read about the space weather modeling framework, go to the Geospace Magnetosphere movie, go down to the bottom of the page, click on the Details tab, and click on Space Weather Modeling Framework. You can read from where the data is derived. Again, that's 4 hours of data. Let's look at ground magnetic perturbations. Changes in the Earth's B field at the ground level. And we see some significant perturbations here. We showed some auroras in yesterday's daily space weather video. I'll let it play through a second time as this is a pretty complicated map. Delta B in the geospace. Changes in the Earth's B field as measured in nanotesla. Like the other Geospace Magnetosphere movie we showed, this is 4 hours of data. And it's courtesy University of Michigan. I just wanted to show the induction in the power grid here. And you can find this. You can find links to this at the Space Weather Enthusiast dashboard. It's the geoelectric field 1-minute empirical 3D model. And you can see some induction created by that incoming coronal hole wind stream. Nothing too major. We just like to show this to remind our viewers of the fact that solar activity creates induction in power systems. While the U.S. is good at shutting down power systems when there's too much induction to prevent transformers from being destroyed, it is an issue. Next, looking at some magnetic data. And we're about to see a big uptick here in the GOES magnetometer readings. So, yesterday's daily space weather video came a little bit late. And, yeah, you may see this graph expand further. It's been expanded to 140 nanotesla here. So don't be surprised to see quite high readings and some significant spikes here, as we've been seeing for the past 3 days. Those sawtooth patterns there are not the normal pattern. Normally you see a little smoother thing there. And for you new viewers, the N's and M's are noon and local time for the GOES 16 satellite. Now we're looking at magnetic data derived from 51 ground-based magnetometers, as well as magnetometers on stereo A at Lagrange 5 and stereo B at Lagrangian 0.4. And the Earth is solidly in a South Pole-oriented current sheet shown there in red. Again, expect to see some big spikes and some high readings on the GOES magnetometer. Here's a line of sight plot which also shows you the solar magnetogram and the poloidal fields. The poloidal fields are the fields that emanate from the solar poles, conical-shaped fields. And it shows you the sun's B field in blue. Expect to remain in the South Pole current sheet for the foreseeable future. Here's a line of sight coronal hole plot, and that red coronal hole there right in the middle of the beginning of the video, that's the coronal hole that's been providing this ongoing stream of high-speed solar protons primarily. And last but not least, here is a magnetic field plot of the solar corona, the sun's atmosphere. And you can see those purple potential field surface source lines associated with that coronal hole. Just moving out of the Earth-facing zone right now. Here's a diagram of the atmosphere. We show this daily to give folks a visualization of altitudes in kilometers. Feel free to pause the video if you need to study this further. And here's another one that shows you the inner and outer Van Allen belts, as well as altitudes in miles of things like the SDO, geosynchronous satellites, GPS satellites, the Van Allen probes, etc. We do see some charging hazards here. Most of them are in the southern hemisphere, over the Indian and Western Pacific Ocean, also some in the northern hemisphere there over Central America, Mexico, and the just north of the equatorial Pacific. Here's the electron flux over the past 3 days, and we've recently gone back into electron flux warning levels, and that SWPC alert threshold, that's 1,000 pulse flux units. It coincides with 1,000 pulse flux units. And let's look at the forecast. After we put it in context with a 1-year chart, there's the solon.info/solar 1-year chart. Again, you can find this on solon.info. That's spelled SOLEN.info. Pretty high levels of electron flux here. Here's a visualization. And we saw some pretty disorganized total electron content yesterday. Some very high levels there, right where you see the charging hazards. No surprise there. And we see a more organized total electron content here, which is typical of higher levels of electron flux. We see more anomalies where the electrons are not where they normally are at low levels of electron flux. And if you're a regular viewer of the videos, you'd probably already know that. So here's the greater than or equal to 2 mega electron volt forecast model. And NOAA's forecasting for even higher levels here as the electron storm continues. And we usually don't see that during coronal hole wind streams, but today we do. So there's the forecast. The green boxes are the forecast, and the yellow diamonds are the observation. Here's a visualization of the ionosphere. This one is courtesy of Bureau of Meteorology of the Australian government. Here at the Smash News Network, we give credit where credit is due, and we cite fraud where fraud occurs. Because, folks, you can be wrong about something all day, but once you realize that you're misrepresenting material facts, now you're intentionally misrepresenting material facts, which is the definition of fraud. I used to be the owner of an insurance agency. I'm well aware of what fraud is. So anyway, that's 24 hours of the ionosphere in visual form. The latest image coming in there at 9:45 Universal Time is looking pretty normal. Check out the Saharan dust situation. There is Saharan dust blowing right across Central Europe right now, as well as bringing in some warm temperatures into places like Germany and France. And we've brought up the particulates here on nullschool.net. The particulates, the DUEX, dust extinction. Don't become extinct, know where dust is. Next, we're going to look at the normal thing, the 250 hectopascal winds. There are the jet streams of the Western world. Look at the kink in the jet stream here over the central U.S. Let's check the surface winds briefly. Powerful low pressure system there in the North Atlantic. Anyway, back to the jet stream. Look at the extreme meridional jet stream flow here. It looks like you're going to have some hot temperatures in Central America and southern Mexico as equatorial air is blown up to those regions, despite it being winter there. It's winter. So extreme meridional jet stream flow here. We've got portions of the jet stream blowing backwards. It is chaotic and all over the place. And a major anticyclone here off the southwest coast of South America as well. Here are the jets of the eastern world. I thought I was going to crash into Earth. And look at the extreme bends here. This 180-degree turn over the southern Indian Ocean. Jet stream blowing backwards over places like Indonesia, Papua New Guinea, the western Pacific, and the eastern Indian Ocean. Jet stream blowing east to west. That is backwards. Let's continue on. Here's a real-time lightning map. And once again, we see quite low levels of lightning as reported in real time by lightningmaps.org. Very low levels of lightning over the past 3 days. It's a lull in lightning. Let's look at pressure cells. By the way, windy.com has a great mobile app as well. So here's pressure. And we'll advance this into tomorrow. There's where we expect pressure to be according to the GFS forecast at noon time tomorrow. And I'm on Eastern time here, located in Lehigh Valley, Pennsylvania. Look at all the low clouds over the Atlantic Ocean. Low clouds galore, as well as a bunch over the northern Gulf of Mexico. Here's what's going on in water vapor. And here's back to the cloud layer. It's the shortwave radiation map, folks. And we've got some more moisture being injected from Canada there into the northern Rockies, places like Montana. A lot of moisture there. Moving into Montana, Wyoming. And an upper level low here moving quite quickly across New England. Here's the U.S. Doppler radar map. A little bit of snow there in western Montana. A lot of rain in western Washington. And quite a bit of moisture on the eastern portion of the U.S. Thanks, Smash Team, for tuning in. Don't forget to press like and subscribe. Share with your friends and foes. The algorithms dislike us. Thanks to our new viewers. And don't forget to check our playlists as well. We put up a bunch of videos yesterday, therapeutic videos, for all of you who are sick of winter. So stay tuned for our bonus features. And I'm going to show you what I saw during show prep today. So here's what I saw during show prep. Sunspot 2804. There it is in colorized magnetogram. There are the umbrae. And you can see a leading North Pole umbra right here, and a trailing South Pole umbra, making that a beta class sunspot. That's what increases the likelihood of solar flares. And let's show the latest imagery, so I can show you how that's changed in the past roughly half hour. And it's still holding strong as a beta class sunspot. I'm not going to try to line those up perfectly for you folks, but there you go. Sunspot 2804. And we've got a couple more features here, such as the 304 angstroms full disk view. So there's 304 angstroms. There are still a bunch of filaments here in between Earth and Sun, folks. The likelihood of coronal mass ejections is still there. We've got some fantastic close-ups here as well. Even one that looks like it might be a coronal mass ejection, but it ends up raining back down onto the chromosphere. Here's 193 angstroms. You can see that coronal hole that's been supplying the Earth with some high-speed solar protons in the lower right. Here's a full disk 171 angstroms view, and check out that filament in the southwest, which would be your lower right. Also, you can see Sunspot 2804 spontaneously appearing. Here's a close-up of that in 171 angstroms, a great view of that new sunspot. And last but not least, some eye candy. This filamentary system in the southwest, leading that coronal hole. And you can see it looks like there's going to be a coronal mass ejection, but it gets pulled back down to the chromosphere. Fantastic view of that. In any case, thanks for tuning in, folks. Remember to stare at the sun. When you're doing so, don't drink. But if you do drink, don't drive. And since it'll never be now again, we'd like to welcome you to the Neo-Renaissance. And may that solar wind be at your back, and that fraud absent from your YouTube feed.